Hey everybody, Sean Farrell here from Miller 3D, your one-stop shop for all your additive needs in the Pittsburgh, tri-state, and Pennsylvania areas. Actually working through a slew of business cases around metal 3D printing, getting a lot of questions around the Metal X, the Metal X process. Trying to understand a little bit more in depth of what that looks like. So I thought it'd be really beneficial to put together kind of a series of videos walking you through it. So, long story short, I know a lot of you are familiar with Markforged's composite materials, but there are really great ways where you can create hybrid parts and integrate the metal with the actual composite that can achieve 6061 aluminum strengths. So, let's dive into it.
There are 3 steps to the metal printing process: printing, washing, and sintering, that are safe and cost effective, which jumps us into the Eiger software. It's the cloud-based slicer printer management software that you can upload all your STL files to and manage all your files accordingly. Eiger also will scale your parts for the metal process accordingly to the materials, as well as prep the file for any other printing process that you're looking to do. It'll slice the actual file and build supports as required for the geometries that you're looking to achieve. So the Metal X is an extruded based technology, extruding material bases around 17.4, H13, A2, D2, copper, which is a very powerful material, as well as many others like Inconel 625 and others in development. So this kind of, after the print is actually done, we can move to removing it from the build plate. We actually have it on these sheets, so you don't have to worry about the parts sticking to the build plate. One thing to make note of is you see the line of white material. It's actually a ceramic. So once we actually get to the center process, that'll actually allow removal from the supports, which are also 17.4, to be very clean and effective. Which brings us to the wash 1. You lower your parts into a solvent in batches to optimize your throughput. Wash times are going to vary depending on the part size and how thick the part itself is. After that, you take the parts, you put them on the build plate, and you're ready for sintering. So the sinter takes the part from a bound powdered part to a fully finished metalled part. In the sintering process, it ramps up and burns off the remaining binding material, and then ramps even higher to that specific material's profile to fuse those powders in the X, Y, and Z axis. Basically, after that, you remove the parts from the sinter, and you have your finished metal parts. But how this process fits you is unique to your specific organization. So if it's an Inconel 625, copper material, etc., don't hesitate to reach out and we can discuss how to scale this based on your specific needs and values. Sean Farrell from Miller 3D. Look forward to chatting with you.